Welcome to our webinar where we want to show you our system inventAIRy XL live in action. First of all, let me apologize for the technical difficulties we had on Wednesday where we planned to have the webinar. Thanks for your understanding. But now let's get right into so what I want to show you today, first of all, I will explain you why is a system designed like that, what do the components do, and then afterwards I will show you a short flight in this rack here at one of our great customers. So let's start. The system basically is a drone that does stock taking. So it's a drone that flies through the racks, flies up, flies down, flies up, flies down, as you will see afterwards. So you might ask, why do we have this huge ground vehicle? Why is it so complicated, to be honest? What's so difficult about it? There are drones, they fly more or less autonomously. So why don't we just use the standard? And the reason for that is that we have two huge challenges in a warehouse. The first is drones fly autonomously via GPS. And we don't have GPS in a warehouse. First of all, it's indoor. Second of all, it's a lot of metal around. So we can't just use the standard. So that's why we use the combination of our ground vehicle and the drone. And the second thing is, drones of this size, usually the battery lasts maybe 10 minutes, 15 minutes, maybe even less. So you can imagine 10 minutes flying back, charging, maybe exchanging the battery. That is not really a system that would get a lot of stuff done. And that's why we came up with that system. It's actually our third system of inventAIRy. We learned in the years that we had the other two systems in operation, and we took all the learnings, but also the feedback from our customers into that. So let me explain a bit, what do we do? So navigation, how we do that is mainly based on a LiDAR, on a laser sensor, which is based here on the bottom of our AGV. And what we do is, first of all, we map the warehouse, and based on this map, the system knows where it is at the moment and where the rack starts are, so it can navigate. For example, I tell them, please go to rack 29, then it will navigate there, it will look at its surroundings via this LiDAR, also do collision avoidance, but most of all also readjust the positioning it has. It has positioning via this laser, but also via the odometry of the wheels. So this is how we navigate in 2 dimensions, X and Y. And then we still need to control the drone. And how we do that is that we have a camera in here that looks up. And it's basically the same as if I would be standing here with a remote control and have a look at the drone and then say, okay, it's a bit too far right, it's a bit too far left, I need to steer. And that's basically the same that we do. We look up and we always know where the drone is and then steer it, so it's always centered above the AGV. And that's how we take the third component, the third coordinate, which is a Z coordinate, and we know like that in every moment where the data that we gather is gathered in a 3-dimensional space. Yeah, that's basically everything about the navigation, or the most important things, I would say. We have more sensors that we use to recalibrate within the rack, because the big problem in a warehouse is that everything changes, and it changes from one moment, from 1 minute to the other. If you compare it to a vacuum cleaner, the vacuum cleaner has a lot easier surrounding environment, because you have chairs, you have tables, you have cupboards, you have all kinds of fixed features that the vacuum cleaner can use to navigate. We have a pallet that is here now, tomorrow, or let's say in 5 minutes, it might not be there anymore. And the system still needs to know where it is exactly. And in order to achieve that to an accuracy below 10 centimeters, we take the only thing that is permanent in every warehouse, which is the rack posts. So we have additional sensors to detect these aisle posts to really be very, very accurate. Then the next thing, what I said, the battery life, or not the battery life, but the battery capacity is very limited, and that's basically the reason why is this so big, because, and why it's called XL also, because you can increase the battery on the drone, but this increases the weight, and if you increase the weight, it will use more energy, and in the end you don't gain much more flight time. And the weight problem we don't have on the AGV, so we put a huge battery in here, and this gives us an operation time of minimum 5 hours. So that's how we did that. And how do we get the energy up there? There is no inductive charging or anything like that. Sounds very fancy. We want a system that works, and that's why what we did is old-fashioned cable between the AGV and the drone, and that's how we get the energy up there where it's needed most. So yeah, that's basically the biggest challenges: battery and navigation. One thing also about the battery, or also about the cable, or one secret that is also in the ground vehicle is a winch. Winch. When we started, we said, yeah, winch, that should be very easy. It's like a leash for a dog. We just pull it in and then it's done. It's not that easy. Trust me in that. It's definitely not that easy. But we managed. We developed that together with our partner. So we have an actively controlled winch, which is also down here. And this ensures that the cable is always exactly as long as we need it. So it's always between the drone and the AGV. It's not flying around causing hazards for accidents. That's about that. Now the big question, what kind of data do we gather? How do we gather data? And this is mostly this sensor module that we developed for this drone. This has 3 barcode scanners. It has light. You will also see that later. It has quite bright light, so we can fly at night when there is no light. And we have an ultrasonic sensor. And the drone comes with a really, really good camera, which has 20 megapixels, which really takes very good pictures. And we gather all of these data. Basically, we fly through the rack and we take pictures of everything, and we scan every barcode that gets into our way. And then afterwards, you have a huge list of barcodes assigned to the positions. So let's say we scan a barcode, then we know where did we scan it, which rack position did we scan it in. And afterwards we filter. You say, I only want the SSCC number, for example, and maybe the count, or maybe the batch, or maybe all of that. And then you filter afterwards only exactly this information that you need, which you can then export and use to compare it to your WMS data, or you import your WMS data into our system. We do the comparison for you. This is basically the drone. What this does, we have additional sensors down here. This question, if you would be with me here in the warehouse, then this question would most definitely come, because you see this AGV is already quite high. You will see that the drone will fly minimum like to a height of this. So basically the drone more or less scans horizontally. So the lowest scan of the drone would be somewhere around here. So we would lose the bottom position, and that's why we have here another camera that takes a picture also of this position, and then the data or the picture is processed to analyze if there are barcodes in it, and if there are barcodes, to read them and to get the data that is in the barcodes. And that, let me think about if there is any other magic that we have in here. Otherwise I would start with a presentation. The other only thing I see is a red button, this emergency stop. Good to have in any case, but better if you never need it. So now I would push the system back to the charging station. Sorry, there is a bit of chaos here, but I hope that's okay. You apologize that. I will restart the system so that it's set, and now I will use the time that it needs to start to explain what we'll see. So I will tell the system, please do a stock take in aisle 31. You see here 31. Before I told the system aisle 31 will start here, and I told the system what are the heights of the levels, what are the distances between the aisle posts, what are the width of the positions. The system will drive here, so I will just click a button. The system will drive here. And when it is here, it will recognize the aisle post, it will recalibrate its position, and then the drone will start. And there, don't get nervous, or let's say I will not get nervous, because this will take some time until the drone is completely set up. It takes about a minute even. It will, I will promise you, it will seem like a very long time to you maybe. But the system is set up in a way, the idea is that the system runs at night. There is no one at night in the warehouse, no one has to supervise it, so this minute will appear now as a very long time at night. No one cares about this minute. Just so you know already, it's all good. I will not worry, the system will start after about a minute. It will start, it will calibrate, and then it will start the process, and you will see how it works. I will explain maybe a bit while it's flying. And then I will just let it fly, and then that's basically what I want to show to you today. And I hope that afterwards you are even more interested and you come back to us, and I will be happy to explain to you everything in detail in one-on-one discussions and answer all your questions. So the system has started. So I will select now rack 31. I will say let's start now, and with now I mean in 10 seconds. So I will wait 10 seconds, and then you will see the system starting. You will see that it drives out of the charging station backwards. It does not have any laser sensors. That's why it will be very careful. If it touches anything, there is a bumper below. You see the blackish thing on the bottom. So it will stop then. And then when it has some space, it will turn. And now it will drive to rack 31. And there you will see the drone will start, as I told you before. So now it reached the point that I told it where it should be. It detects the aisle post, so it really knows to the centimeter, to the millimeter even where it is. You saw that it adjusted itself a bit, because it recognized that it was a bit tilted. It should be really parallel to the rack, so it will just drive straight. That's why it recalibrates itself a bit. You saw the drone turned on, and now it will start up all the systems on the drones. The sensors will start so that everything is ready, which will take, as I said, some time. I will think about what else I can tell you. We have LED lights on the back, red, on the front it's green. What else could I tell you in the meantime? Or we just wait? I will just let you wait in silence, and then you will see when it starts. I know what I can tell you. You see these LED lights that are reflected here on the surface. This is also one of our greatest inventions, and that helps us to see the drone's position. And now you see it started, it recalibrates, or the drone calibrates itself in the flight. And now the process starts, the drone will fly up, and it will just scan every barcodes that are somewhere on the pallet. You see the pallets are very nicely GS1 conformed, so the barcode is always on the right side. We have two ways of operation here. One is we fly, I will call it lanes. So you see the system is not positioned in the center of the position, because we will fly lanes like that. We can adjust the distance to rack, because we basically say if we fly 1 meter distance to rack, the barcode scanners and the camera, they will scan about 1 meter. So what we say now is that we scan 1 meter, and in order to have everything on the pictures and everything, we will not drive 1 meter further, but a little bit less. So we have kind of an overlap, so we guarantee that we have everything on the pictures. So like that we can adjust the distance, we can adjust the overlap. For example, if you have very big barcodes, good for you, we will drive further away from the rack, and like that we have more on the pictures, and we don't need to drive, or we can drive further with each step. So we will be a lot faster in the end to scan your racks. We can also adjust the overlap. If we go from 10 to 20% or to 5%, this will also speed up the process. This is one way that we do. The other way is that we fly positions of the pallet, because what you see here, I don't know how much in detail you recognize it, but we actually flew more than one time per position, which means this takes time, of course, and in order to speed up the process and to optimize that, you can select that you fly really lines of position. So we say we position ourselves a bit right of the center of the pallet, and then only fly that. Like that, if you have GS1 and you put your labels always on the right side of the pallet, then this can speed up your process by, I would say, 30–40%. And like that we gather all the data. Yeah, and that's basically it. You see, I've seen that a lot of times in warehouses when we do live demonstrations. The people, the spectators, they have a look and say, wow, that's really, really great. Drone flying a warehouse, crazy. And then about at this point, they will start talking. They will start talking and say, yeah, that's good, that's fine. And basically no one will watch it again, watch it still, but they will discuss what it's used for. And that's especially my goal. I don't want a fancy system that flies around crazy through the warehouse. I want a system that works in the most safe way. It doesn't have to be interesting. It has to work. It has to provide a benefit to you. And that's what this system does. It flies up, it drives to the side, it flies down, it drives to the side, it flies up. And yeah, basically also based on our experience, what we saw is that this is really not an interesting process, and that means it would be very sad if someone would have to supervise the system. And that's why one of our main focuses was that that this system is really autonomous, so that you don't need anyone doing anything. And that's what we achieved here. You see, I don't do anything. There is no one hidden around here somewhere flying the drone. No one would be able to fly a drone that's stable. I can tell you, I would say we have almost the best drone pilot in our company, and he will not be able to drive that stable. Yeah, so really basically you start the system, you can plan it ahead. You can say at night, tonight at 9 o'clock I want to start, tomorrow at 6 please be back in the station, because then the usual operation starts. So you say that, and then you leave, the system will start as you saw, and it will do all the work. Yeah, give me 1 second to think if there is anything else I want to tell you. Maybe one thing, I told you a lot, or if you look at this warehouse, this is a really nice warehouse. It's very ordered, I don't know, ordentlich in German. Very structured, very much to the standard of GS1. But if you have another warehouse which is a lot more difficult, you might have like 10, 20 different kinds of labels. They have all different information. We are very, very flexible on that. You define exactly which information you want to have. You define it in our system, and then you get the information you want to have. Also, if you change the rack layout, this is one thing that you can also do yourself. The mapping and stuff like that we do at the moment. There's a plan that you can also do that by yourself, but let's be honest, how often do you change the positions of your rack posts? This happens very seldom, so with this will be in the future, you will be able to do it. At the moment we do it. And how we do it, or our approach is, we take 2 days for a whole implementation. Our approach is after 2 days the system is 100% ready to do everything you need. So we will come to you 1 day implementation, the mapping, to set up the layout, to set up the barcodes, to set up the export as you need it, the import as you need it. 2nd day, test flights, optimization of parameters, but also training for your staff, which, to be honest, will be very short, because it's a click of a button, as I said, which is explained very, very fast. Yeah, so that's basically how it is. And now I would say with that, I will not talk anything boring now for the rest of the rack. With that, I want to say thank you very much for attending the webinar today. I hope it was interesting for you. I hope you understood the system better, and now I'm looking forward to your questions. I offered that we do one-on-ones afterwards. I'm very open to that. Let me know. We will talk, I will answer all your questions, and we discuss the opportunity that our system provides to you.